Okay, now we got some more examples here. And according to these ones, we'll solve by subtraction, but I really think we've already done this. So over here we got solve each equation, check your solution, and these are going to be doing all right. 142 plus d equals 97. Now I've already kind of talked about this, but you wouldn't have to bother saying that there's a positive number out there. I look on the left and I see that d is not already isolated to one side, so it's not by itself. There's the word isolate, kind of like in the corner, you know, like somebody would be isolated away from the rest of the group. Because d is not by itself, we need to get rid of everything that's near it. I see 142. I'm going to remove 142, writing that directly below the numbers on both the left and right side. Now, I would never put an equal sign here. The reason I wouldn't put an equal sign there is because this is a step. I'm performing some action. So here's me taking away 142 from both sides. I know those cancel out because 142 minus 142 is 0. And then on the left side, the only thing that remains is d. I'll bring my equal sign down. Again, look how neat that is. And I'm going to end up typing this into the calculator if it's tough for me. But if it were to talk about integers, I do know that these are opposite symbols. It's like a positive 97 and 142. So were this something I could do quickly in my head, that's how I would do it. You know, I just take away those values and then I realize, oh, well, the negative is larger than the positive, so I'd have to have a negative result for my answer. I box my solution, and now it's time to check it. And yes, I do want you checking these for the original sets of problems, for these types of problems. Here's 142 plus a negative 45, and that is equal to 97. 142 plus a negative, that's the same as subtraction. Now you'll notice I'm not explaining everything every single time. And if I type that into my calculator, I do get 97 as 97, and I move on. Do the next two on your own, and I'm just going to put the work up in about 5 seconds. So pause this and do them on your own, including the checks. Go through and make sure you have everything nicely set up like I do. If this 27 is over a little bit to the right, that's not good enough. Get the equal signs in line. Make sure you've boxed your solutions. Make sure you've checked over here. And again, we don't box these because this is not our solution. That's just the check part. Over down here, if you forgot your line, add that back in. And then also, here's p is negative 28. Notice that I did this step and then rewrote it. Later on, if you're okay bypassing or skipping that rewriting part, you can go straight to this, because it's like, oh, I know, I'm just going to shuffle it around in my head, no problem. Go ahead and be my guest and do that, but make sure that everything is pretty rigidly stuck to the way I'm doing this. And the reason that I want that rigidity is because I want it to match my procedures, because these are excellent strategies so that you can do way, way, way more challenging stuff. And so, yeah, you're probably like, well, I could do this one in my head. And yeah, I'm happy, I'm proud, I'm glad you can do that. But that's not what these are about. They're not about doing them in your head. You are learning steps to do things algebraically so that you can take that further and do way more intense and challenging math in higher grade levels. All right, now I like to use the term curveballs. And the reason I like to, call certain math problems curveballs is because as we do work in a math class, we get so incredibly used to things going right down the middle that then when we swing, we can just knock the ball out of the park all the time. We get handed these pretty straightforward, non-tricky questions. But then all of a sudden, the math textbook or the teacher or whatever kind of throws something, and it seems like it's coming at you at the right angle, but then it dips, and it totally throws you off. So it's sometimes like you're in class taking your notes, and things are feeling pretty good. But then you get home and you have your book out, and all of a sudden all these curveballs show up, because it's pretty unrealistic to expect your teacher to show you every type of problem. So I'm going to call those curveballs. And so on these ones, always try and simplify before working. So many times, and not just math, but in many things in life, we jump right into doing something, as opposed to assessing the situation and figuring out really what's going on. So if I jumped right into this, I'm going to use red to kind of show a poor way to approach these two problems here. So maybe on this first one, someone's like, well, I know I always do the opposite of whatever I see there, so I'm going to add a negative 5 to both sides, and, well, that feels weird. I get 5, and maybe I check it out, and I think I'm okay. But there's definitely a shorter way to do this. So I'm going to erase this. And if you get through this problem and you want to jump back and look at what I did here, do it. But I look at this original equation and I'm like, well, that minus and negative, you can go ahead and write on this work. Well, you can just make the signs opposite. So turn them both into pluses. Plus plus doesn't do anything, by the way. Plus plus is the same as being positive. But I'm flipping those negatives because I know that two negatives become positive. Okay, so if I instead have that, now I can write x plus 5 equals 10. So I've simplified the problem before jumping right into the work. I've figured out that I can now look at a much more clear and simplified problem. So here's x plus 5. Oh, cool. We've done these a ton now. I can just take 5 away from both sides, and I have x is equal to 10 minus 5, which is 5. And I box it. And then when I go to do my check, maybe it gets confusing because it just looks strange. But here's 5 minus a negative 5 equals 10. Then within that same step, I can turn those to pluses, and then 5 plus 5 is 10, which equals 10. So if you want to, you can jump back and look at what I had before, but I promise you it was much uglier than what we just did there. So here in this bottom one, I have this red ink where I've gone through not one, but two different algebraic steps to eventually work my way to my final answer. So let's see what this would look like if I instead simplified first. Ignoring the right side, is there anything that I can combine or put together on the left? Well, I definitely can. I can put together 8. Put together 3 and 5 and get 8. Maybe I write the y first because there's just a plus sign in front of it and I'm sneaking it out front. And then instead of having plus 3, I have plus 8. And that would be equal to 10. So y plus 8 is 10. We've done those a lot now. It's just like the last one. So now I have y equals 2. And I've actually done less algebra in this, and by algebra I mean more of the parts of moving things from the left to the right side or removing equal quantities from both sides. Instead I've just simplified at the start, and then now I can go to my check, and I write 3 plus 5 plus 2 is equal to 10, and this is not very taxing on the working memory, so it's not like you have to be like 3 plus 5 is 8 plus 2 is 10. You can just go to the very end, make sure you don't add incorrectly, and see that 10 does equal 10. Alright, now here's another curveball, and by curveball I mean this looks perhaps really ugly. And if I look on the left, ignoring the right side, I have 1, 2, 3 separate terms. If I look only at the right side, I have 1 and 2 terms. So this whole equation has 5 separate terms. And when I look at this, I'm like, well, negative 12 plus 12, that's 0. I scan through everything with my eyes on the left side. I've eliminated these 2 terms. I could end up writing 0 plus x. But if I'm feeling confident enough, and I think I'll remember how to do these, I'll just write x all by itself on the left side. Now I know that anything times 0 is just 0, which means that the only thing I have remaining is minus 4. Now if you want to make this complicated, you could be like, well, 0 minus 4 is equal to negative 4. But all I do is I just see that there's a minus sign in front, and I'm like, well, that means it's negative 4. Now, your teacher says, well, you got to check them all, right? Well, we didn't really move things around or anything, so this check would probably be more just going on in your head. So let's check this. Well, okay, basically a check for this means revisiting and doing it again in our head. Okay, cool, that went away, yeah, I'm good there. Okay, I brought my x down, yeah, good. That went away, okay, cool, yeah, I'm good. So my check is less about redoing the math and more about, it's less about plugging back in to the values there and more about just redoing the entire problem in my head to make sure that we're good. So this is the second video for this section where we solve things through subtraction. We looked at some curveballs, as I described, where maybe they don't come straight down the middle all the time. And then one where we didn't even bother doing the check because it was more work than it was worth. and we'll save word problems and other things for another video.